So this lesson is given one trigonometric ratio, find another. And the key is in the learning goal like often, and we're going to use Pythagoras to find all trig ratios given one. We don't necessarily have to find them all. We'll let the question dictate it. But the point is that we can actually find them all if we want to. Okay, let's get to the example. So we've given that sine theta equals 2 over 5. Important thing is that 2 over 5 is actually positive. So if we go back to all stations to central, with just the information we're given right now, so we know that it's going to be here and here, all right? So that's really important because when we find cos and tan, we're going to have two answers, a positive one and a negative one. But how do we find cos theta given that sine theta equals that? Well, we'll go back to our triangles. If I've got a triangle here, and I'm going to try to do it a better way. Okay. There's a right angle there. And I know that theta is there, so what would sine theta have to be? Would it have to be 2 over 5, given that sine theta is opposite over hypotenuse? Now, is there a skill that we can use to find out what x is? Well, of course there is. We've been learning it since year 8. It's called Pythagoras. Okay, and because it's a shorter angle, we can just go x squared equals 5 squared minus 2 squared. Okay, that's just a rearrangement of Pythagoras' theorem. So x squared is 25 minus 4. So x squared equals 21. So therefore, x equals square root of 21. Now, because we're talking about a length, like the answer is plus or minus 21, but we're really only interested in the root 21 because we're looking at a length here. So that equals, and I'll put it in blue, root 21. Okay? So what will cos be? Cos theta is adjacent over hypotenuse, so it's going to be root 21 over 5. But because it's not only here, it's also in this one, because sine's positive in both of them, we have to include the second angle as well. So it also equals minus 21 over 5. Okay. Now we do the same with tan. Now I know that tan is opposite over adjacent, so we just put that in. Now also the case is, because it's in the first and second quadrant, if it's in the second quadrant, it will be negative as well. Okay, so hopefully that makes sense. So we're just using Pythagoras and trigonometry, and we're just combining them, and it will be something that will happen from now on because right angles is what they have in common. Okay, let's look at this last part, and you've probably been looking at it. I didn't want to talk about it. But now it is known that theta is obtuse. Okay, now by definition, obtuse is between 90 degrees and 180 degrees. Well, it's a bit more than 90, a bit less than 180. So that means it must be in this quadrant here. Okay, it must be in that quadrant. So given this information, what is sine theta, cos theta, and tan theta? Well, hopefully we know that sine theta is still positive because it's still positive in that second quadrant. Cos theta in that second quadrant will be negative, so we're just using that negative one. And tan theta also in that quadrant, because that quadrant only sine is positive, will be negative 2 over root 21. So if I were to recap the main points, is that we always need to do our all stations to central. It is key to what we're doing. And then we just answer according to what the question gives us. Okay. So at this stage, when we first did it, when we were just looking at this side, we didn't know anything about theta. We just knew something about sine theta. So we went with it. That's why we had our two answers. But here we have further information, And that narrows down, and now each one of these trigonometric ratio has exactly the ratio that it needs to have. Okay, well, that's the end of the lesson. Peace out.